Hello again, everyone. This video is going to run through the process of synthetic division, an alternative to long division. On the left, you'll notice the long division that we had performed in class earlier. One of the things you hopefully notice about the long division is that because it's an algorithm, there's a lot of repeated steps. And because of the repetitive nature of it, it allows us to condense some of the writing down. Now you might think, okay, this isn't so bad, but say you had maybe like a x to the 7th, that could be a really long, long division calculation and take up quite a bit of your page. So what we're going to show now is this is a way that sometimes can condense this a little bit and make it a little more shorter to write. I'm going to show a lot of extra stuff just to help kind of organize the method, but if you like this method and if you do it enough times, I would bet a lot of you will probably just start omitting some of the extra stuff that I'm showing. So we're going to start by making basically it's kind of a cross chart thing. To start setting this up, we take the divisor, the x plus 1, and we set it equal to 0. So when we get x equals -1, this is going to be a possible 0 for our polynomial. Reason I'm saying possible 0, you'll see a little later on when we actually use division to help us find all the zeros and solve equations. So that will go into the corner of our chart. Next, I'm going to label all of the possible degrees of the term, starting with the highest and then counting down. So I'm going to start with x to the 3rd and then count all the way down to the constant term. Notice how every single term with every single possible degree has to be accounted for. Even though there's no quadratic term, I still need to have a space there for the x squared. So I count all the way down, starting with x to the 3rd, all the way down to the constant. Next, I'll put in all the coefficients, and again I have to include a placeholder 0 for the 0x squared term. Once I have it set up, the synthetic division algorithm begins by bringing down the first number. Notice that because I'm just dividing by x, the coefficient is still going to be the same. It's really important to draw an arrow there or do something to make sure that you don't write any numbers directly under that first 4. Obviously, because it's an algorithm that keeps going, if you shift everything one space to the left, it's going to mess up everything else in the entire problem. So put something to make sure that you're not tempted to write any numbers where that arrow is. The second step of the synthetic division algorithm goes along with the multiplying part in the long division algorithm. The second step in the synthetic division algorithm is to multiply diagonally. So I'm going to take the 4 from the bottom and I'm going to multiply it by the -1 in the corner, and I'm going to put the 4 that I get as the result into the next column. You'll notice that the -4 that we got by multiplying the 4 times the -1 is exactly matching up with the -4 that would be in that part of the long division algorithm. The final part of the algorithm is to add the numbers vertically, which again you can see goes exactly with the subtracting part of the long division algorithm. So 0 plus negative 4 gives me negative 4. And now all I have to do is just keep repeating the algorithm until I get to the end. So negative 4 times negative 1 will give me positive 4. Negative 7 plus positive 4 will give me negative 3. Negative 3 times negative 1 will give me positive 3. And 8 plus 3 will give me 11. The final thing we need to do is just interpret our quotient. Since we're dividing by an x, everything is going to drop down by 1 degree. So x to the third will drop down to x squared will drop down to x to the first, x will drop down to the constant term, and the constant term will become the remainder. And then what you'll see is that you have exactly the same answer as we did in the original long division problem. So again, notice that we have the same quotient as we did when we did the long division way. 4x squared minus 4x minus 3 plus 11 divided by the quantity x plus 1. Now, this method only works with a linear divisor and no coefficient. If you're dividing by x squared or dividing by x to the third or anything higher, you wouldn't be able to do it. Also, if you were dividing by, say, like 2x plus 1 or 3x plus 1, you wouldn't be able to do it either. Now, there is kind of a way you could fudge that a little bit and make it work. If you're interested in it, it's actually a really interesting thing to look at, but it's going to work differently. So for the sake of simplicity, only use this method when you have a linear divisor and then no coefficient with it. So here's another example from that sheet if you want to see one. I start by setting x minus 2 equal to 0. So 2 is what's going to go in the corner of my synthetic division chart. My highest degree is x to the third, so that's where I'm going to start. And I'm going to label all the way down, starting with x to the third, and then x squared, x, and the constant term. I'm going to label all of my coefficients, so 1x to the third, minus 1x squared, minus 1x, minus 2. I'm going to bring down the 1, again putting an arrow there so I don't accidentally write anything in that space. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. And then negative 2 plus 2 is 0. So actually, this is nice because our quotient doesn't have a remainder. Last thing we need to do is just relabel all the columns so everything drops down by 1 degree. And then the last thing we need to do is fill in the coefficients to write the final answer for the quotient. So x to the third minus x squared minus x minus 2 divided by x minus 2 is x squared plus x plus 1. And then since there's no remainder, I don't have to write anything else besides that. So that's how you do synthetic division. If you like it when it works, that's great. Otherwise, long division will always work all the time.